Hey guys, we're doing some more soldering. I recently bought one of these electronics soldering kits. It's a little Tetris game, and yeah, so it's also my first time using a LCD microscope, and in this video we will test out this unit in more detail and see how it compares to using these traditional magnifying glasses. The microscope is from TOMLOV. It is the model TM4K-AF Flex. Now, disclosure, this is a product I received for free to integrate in a video. As always, I'm not getting paid. All the opinions are my own, but I do get to keep it. And here we have the Tetris soldering kit. It doesn't have too many parts, and soldering it, well, it went actually pretty smoothly. The first components are two capacitors and a little resistor. The capacity actually needed to be put on the side. That was a mistake. I later corrected that because otherwise it doesn't fit underneath the little microcontroller. And here we go. We are soldering on the resistor. This is one of the legs. And here's the other one. So beautiful with the microscope. You can see all the detail. And now off to the capacitors. So throughout the video, I tried soldering just looking at the monitor. Sometimes I looked with my eyes onto the PCB so I could see what was going on and have that 3D feeling. But in the end, I used a hybrid approach, looking at the PCB board with your eyes and then position the solder iron and the solder wire, and then looking at the screen to do the last fine work that way. Because yeah, through the screen you can just see a lot more detail, and it's just very beautiful to see the solder flowing and all of that. Also nice is PCBWay, our channel sponsor and your one-stop shop for printed circuit boards, manufacturing and assembly, and much more. For example, they have a shared projects database where you can find ideas for your next soldering project, like this one, the Silly Sound Bastard from Necro, where we have collaborated with him in the past with the Voltage Blaster. So this is a Covox SpeechThing sound device, and I will put links to this project down below in the video description. The microscope came in a huge box, and inside was another box, so it was very well packed. One key highlight of this microscope, and this is why it's called Flex, is the flexibility of this arm. You can just swivel the whole microscope out of the way, and then your bench is free and clean for your next project. And it also means that you don't have the limitation of a base plate with the arm mounted here. So you can use really large PCBs like a motherboard, for example, or objects that are bulky and heavy in size. So this is the main difference between this one and some of the cheaper ones that come with a base plate. And the other key highlight of this product is it has autofocus. Now it has 3 modes. At the moment it's set to manual focus, and you can use the plus and the minus buttons to dial in the focus manually. You can also use autofocus in single shot mode. So you just tap the AF button one time and then it will focus automatically on the subject. But if you hold down the AF button, it will go in full-time autofocus, and that means whenever you adjust the height, for example, it will focus again. There's a bit of hunting going on, but this is very convenient if you, for example, use a PCB holder like I do and you rotate the board around to insert some components. So it's very convenient. The autofocus works pretty well, I would say most of the time, but I did run into a few issues where it just doesn't quite get the focus right. In that case, I move the PCB around a little bit or try from a different angle. Next, we have a socket. This is for that huge microcontroller or processor. I'm not quite sure what it is, but yeah, so the socket comes first. And my process is I'm gonna solder one of the corner on opposite sides to secure the position. So this is the first one. And here comes the other one diagonally on the other end. That way the socket is nice securely in position and I can do the other legs easily. And this part is quite fun. You can really see me feeding the solder wire into the joint. I really like this part because there are no long wires that are in the way. Really clear visibility. With this joint, I thought there wasn't enough solder. You can also see the solder spitting onto the PCB. I'm curious if you know why that is. Maybe it's just the quality of my solder wire. And yeah, this part is really enjoyable. You just work your way and do all the legs. The installation is pretty straightforward. Now, most of you will install the microscope on the tabletop bench, but you can also install it on a top shelf, which is what I did. So there's a little bit of flexibility. The C-clamp is huge and should fit most situations. Unfortunately, I noticed that the microscope is not fully straight. There's one part and it's a little bit crooked. Maybe the welding didn't go as smooth. So that is some feedback for the company and for their quality assurance department to do a little bit better in the future. The way the microscope is mounted to the arm and also the way the ring light is mounted, it's not really very secure. It uses these screws, and even after tightening them really with a lot of force, there's just a lot of wiggle room and movement, so it's just not really as stable as I would like it to be. There's also some wiggling going on with this part here. I've got some close-up footage for you to take a look. Here I'm doing the other side. I zoomed in a little bit more to really see the detail. You can even see how the solder slowly turns from liquid into solid, and you get that nice shiny surface at the end. This is with solder wire that contains lead. Be sure to always wash your hands afterwards and don't touch your face while soldering. Lead is not good for that. The USB port is next, and to be honest, without the microscope, I think this would have been a really daunting task, but yeah, I seem to be doing an okay job. So from one side with the solder iron, make sure the pad and the USB port, the legs are getting heated up, and then feed in the solder wire and off you go. And here we are on the other side. They're just 2 pins that we need to solder on. I'm using a little bit more solder wire for this one, just to give it some stability, some integrity. Next comes the on-off switch. This is when you use the Tetris game in battery mode. Nothing too complicated. There are 5 pins that we need to deal with. Again, this one is exposed to mechanical forces, so I'm making sure I'm using enough solder, maybe more than you have to. I'm not quite sure, but I want to make sure it's a solid solder joint and that it stands the test of time. And yeah, again, you can see beautifully the solder melting and flowing. It's just mesmerizing to watch while doing this process. It comes with all the cables. Specifically, you need a USB cable and then connect that into the 5-volt 3-amp charger. The ring light also has a connector for mains power. The cables, they should be a little bit longer. They barely make it to my power splitter, which is actually elevated from the floor. So if your power board is on the floor, then the cables might actually not be long enough. For the USB, it's not a big deal. You can just buy a longer USB cable, but the mains cord into the ring light, you will have to buy an extension cord. What is nice, there is some features for cable management, so it's a nice setup. This microscope has a fixed lens, so it's not one of those where you can swap out the lenses to adjust the magnification. So to zoom in, you need to adjust the height, and there is a dial here. You can rotate that to lower the height of the microscope. If you need to go even lower or higher, there is a clamp here, and you can then adjust the height of the microscope on the mounting arm. We have digital zoom, so I can use the remote control and then zoom into the image here up to 4x, but it does mean you will lose some detail because it is digital zoom and not optical one. It has a built-in battery and it charges through the USB-C cable. The USB-C port, you can also use it to connect into a computer, and I will talk about those features shortly. Here we have a little display for the score. Off we go, same process. Use the solder iron to heat up the pad and the pin from the component, and then feed the solder wire from the other end. Then after you remove the solder wire, I leave the solder iron on the joint for a little bit longer just to make sure everything is fusing, but as I'm watching this, I can feel that maybe I'm pulling the solder iron a little bit too fast sometimes, but either way, it seems to be working quite well. And there's the last one. We are almost done. Next up, we've got these huge LCD screens. I don't know what they are called, but they are for displaying the Tetris bricks and the game. A little bit awkward here. I'm using my left hand to both hold the component in place from the other side, as well as feeding in the solder wire. And then it's just a matter of soldering each pin nicely and beautifully. Again, you could see the solder spit all over the PCB. Later I will use some alcohol to clean it and a little brush to make sure that any excess flux is dealt with. Me being a content creator, the ability to video record what's on the screen is definitely a key highlight for me. So it has a micro SD card slot at the back, and it comes shipped with a 64GB micro SD card. But it's almost impossible to remove unless you use a tool. So in order to access the SD card, you plug in the USB-C cable into your desktop computer, and then you can navigate all the files. Video files recorded internally on the SD card are stored in 4K, so that's a nice resolution. Unfortunately, the USB connection is only USB 2, so that means the data transfer is quite slow. You need to be quite patient to wait for the copying of all the files to complete. The recordings are also split into many smaller files, and I had a look. It turns out each file has a length of 5 minutes, so that seems to be some sort of a limitation of this product. So that means if you have a longer recording session, you need to put everything back together in your video editor. At the back of the microscope, we have a HDMI port. It's one of the smaller ones. It does come with an adapter cable, but again, it's quite short. Now, using that, you can use OBS, and I tested this. Unfortunately, you are limited now with the resolution. We're only getting 1080p, not 4K. And there's one more way to capture the video, and that is through USB. So when you connect the USB-C port to your computer, you can actually change it into webcam mode. It pops up with a option on the screen. You press OK, and it now functions as a webcam. It does support 4K, but because we're using a USB 2 interface, there's huge delay between what's on the screen and what you see in OBS. I've got some demonstration footage of that. You can lower the resolution to 1080p, and then that delay disappears. But again, we don't get that nice 4K that we get through the SD card. And to make matters worse, with the USB webcam mode, you are locked out from the menu, so it's really a quite limited experience. And here I'm placing the buttons onto the PCB. So these are for controlling the game, basically. And here we go. This is me soldering on those buttons. Again, these are exposed to some mechanical force, so I'm making sure I'm using enough solder wire. By the way, I'm using 0.5 millimeter. I've been told to use the thinnest for the job, but maybe for this project a slightly thicker one would have been just as fine, and then you don't need to feed the solder wire as fast as I have to do here. Next up is the beeper to play some music and some sound effects. And Q1 855, I'm not sure what component that is, maybe a transistor or something like that. Here we are on the back of the PCB. So again, an easy process, heating up the pad and the wire and then feeding the solder wire from the other side, or at least from another angle, not directly onto the solder iron. There you go, last pin, and we are finished with this part. There are two buttons here, P1 and P2. Those are presets that once you've got a focus, you can save it under P1 by long pressing this button here. And then let's say you adjust the height of your component like this. You can press P2 to lock in this focus point, and then you can quickly switch between them by pressing P1 or P2. The microscope has built-in lights, and there's a touch sensor here to adjust the brightness. There are some LEDs just around the optical sensor. I will put some photos on the screen. The other light source is the ring light, so it's got an on-off switch here, and then a little dial for you to change the brightness. The screen can be tilted, but mostly backwards. I wish it can go down further, but it's blocked right here. So if your screen is very high up, then it's a little bit awkward to see what's going on. And we are almost done. The last step is just soldering on the battery compartment, but this is optional. You can just power it through USB. And now let's have a look. Does it work? Let's check out the finished product. We will now go over the on-screen menu options. There is a nifty feature. By pressing down and holding the OK button, you can switch into various modes. The most interesting one being this one, which is a split screen mode. So we can have a zoomed in version of this little window over here. Pressing the OK, long pressing it once again, this will activate a freeze mode, so press OK, and now it freezes what's on the screen. Pressing it again, we will go to photo mode. In photo mode, whenever you press OK, it will capture a screenshot, a photo, but you can also use the remote control, just push the photo button on here. What's also nice is if you press OK on the remote, it will trigger the autofocus. That's very nifty because you don't need to touch the microscope, so there's no wiggling going on. You have a nice steady position. And long press it one more time. We go into video mode. Pressing OK now will start the video recording. You can see a timer here, and you can also see how much more storage is available on the SD card. And here you can see an indicator for the number of files. The menu has a lot of options, so let's navigate into playback. So here you can navigate the files on the SD card, like the video files and so on, the photos, and you can also lock files, delete files, and so on. But personally, it's much more convenient to plug in the USB cable into the computer and navigate from there. The next screen, we have image options, and there are lots of them. The first thing I noticed, well, I don't like auto exposure, so I changed it to the manual one, which is called lock. And then I like to go with these settings: exposure time 100, gain 70, and then I also turn on WDR. This is some sort of a dynamic range feature, boosting contrast in dark areas. But unfortunately, whenever I power cycle the unit, it goes back to auto. So that's really annoying. All the other settings seem to get saved, but this particular one always resets. White balance, I calibrated it by just putting a white piece of paper under the microscope. And then here you can set the autofocus, auto manual. That's the same as using the button down here on the arm. You've got effects here, so black and white, for example, or negative colors. Let's go back. That's what this looks like. Let's go back to color. And there are more settings, saturation and sharpness. You can also flip the screen horizontally or vertically. That's if you want to mount it upside down, for example. That's for flicker reduction, depending on where you live. More settings. Under shortcut, you can define which is the first menu when you press and hold OK. So that's split, freeze, photo and video mode. The resolution for photos, the resolution for video, LCD brightness, auto power off, language, date. You can reset the settings to default. You can format the SD card, and here's the version of the firmware. And here we can set a cursor, for example, a ruler or a little cross. So let's just adjust that. Go here, ruler, there you go. We can see it here. Or if you want a little cursor, it will be right in this position. We can configure a total of 8 individual lines. So that's a little bit tedious how this works. So first you choose a line index. Then you configure, yes, I want the line to show up. It is here. Now you can configure, is the line vertical or horizontal? Let's go vertical, it's over there. And then you can change the position, but also the width. Let's make it fatter, there you go. And line color, let's go with blue. So by playing around with this, of course, you can also adjust the position with this option. So by setting this up with 1, 2, 3, 4 lines, for example, you could set up a grid of, what is it called? Rules of thirds. Yeah, you can set up rules of thirds to have a more aesthetically pleasing composition. So guys, what are my thoughts using a LCD microscope instead of the usual magnification goggles that I tend to use before? Well, this is my first big soldering project and it worked really well. And to see the soldering process in action up close, it's really beautiful. You see how the solder flows and how the solder and everything joins together. It's absolutely mesmerizing to watch it in magnification. There's definitely a learning curve because you're missing that 3D aspect. So it's hard to judge how far away from the PCB you are with your soldering wire and your solder iron. So in the end, I use sort of a hybrid approach. I use my eyes visually to put the wire and the solder iron close to the joint, and then I look on the screen and then I just put the tip on the joint and then feed the solder wire, and that worked pretty well. Now, as for this particular microscope, as you saw throughout the video, I ran into a lot of little areas that I think should be improved, and I hope TOMLOV takes this feedback constructively and improves with further products. At the time of producing this video, you're looking at $300 US, so it's not a budget microscope, and I think they do need to improve some of those aspects to make this a really highly recommended product. Now, despite all the little issues, in the end of the day, it does what I want to do, which is, not using my poor old eyes and seeing the soldering process in action, but most importantly for you guys, being able to capture everything in nice quality, in high detail, and producing more content. So in this aspect, it's a really fantastic tool and a huge upgrade compared to what I had before. As always, if you're interested, have a look in the video description. There might be some coupons, there might not be. The prices, they're always subject to change. So that's why I don't lock down any promotional details inside the video. Have a look in the description and see if there's anything for you on offer. And now guys, I want to hear from you. What is your soldering experience? What do you use? Do you have a LCD microscope, and how are you finding it with managing the lack of 3D aspect? I know some have an even more expensive microscope with stereo, and then you have that 3D effect, but these tend to be quite expensive. If you do have one of those, share the model down below. I would love to hear what you guys are using. Always eager to learn. And as for the Tetris game, I will try to find some links also if you're interested in buying one, but also check out the links from PCBWay, the shared projects. Maybe there's something on there that you want to try out and practice your soldering skills. I have already bought some more soldering kits. One is a FM radio and another one a little calculator. And that's it from me. I hope you found this video useful, and Thank you so much for watching, and I shall see you soon with another one.